The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Continuous process improvement. We're going to need some improvement here. Can we agree on that? Or did it flow seamlessly? You're happy? Maybe it feels like something you're already used to, so hard to see the difference. All right, so at the end of this, you should recognize the PDSA or PDCA. It's Plan, Do, Study, Act. Your notes, I think, say Plan, Do, Check, Act. It is the same. We just like the study better than the checking, and because you need to see, follow up on what your changes they actually mean. We'll get to that. A bit about A3 thinking, and there's a lot more about that tomorrow. But it is as effective improvement process approaches. So, and you should be able to use a framework, a continuous process improvement framework for bettering your system. You should be able to apply the value stream mapping. We did a little bit about that yesterday. I know it was short, and you'll do some more now. So it should help you get that concept more under the skin. And then we'll do some root cause analysis as well. And we talked about the 5 whys yesterday. We'll get into that more now. So what is it, this Plan, Do, Study, Act? Well, it's something that we use because for improvement. And you use it as a problem-solving tool, and you use it as something that will give you an overview of what you're doing now, how you plan your changes, and then actually doing those changes and remembering to follow up on it. It's also so that we try to solve problems in the same way, because that way it's easier to integrate work in the organization, and instead of working in silos, you can work across as everybody is using the same methodology. The A3 thinking is built on the same as well. All right, so A3 thinking, collaborative problem-solving approach, and it gives us a logical approach to how to solve problems. It tells you something about where are we now, what is the strategy of our organization, where is it that we want to go, and how do we plan to go there? And A3, do you know what A3 stands for? It's a paper size. Yeah, exactly. You know A4 paper? So in Europe, we don't use the letter format. We have something called A4. Double size A4, it's more or less double size letter, is an A3. So A3 thinking is your plan for improving something that fits within an A3 size. So it forces you to be very concise. You can't go on rambling about this, that, or the other, because there's simply no room for it, right? And it does fit within that size. It takes a little bit of practice maybe, but it does. And again, what is so important about it is as well, if everybody in your organization is using this, you can collaborate because you know that your partners, they are thinking the same way as you are, which is really important. Right? If you think about it, how it is now, in many places, people, they solve problems totally different. Some departments, they have a chair who's maybe a dictator. This is a problem. This is how you'll fix it, right? Others say, okay, let's sit down and let's think about how we can do this, and you brainstorm, and maybe you come up with who does what, or maybe you just come up with a lot of ideas that are sitting there and collecting dust, right? But this gives you really a platform to do it the same way, everybody, which is nice. Okay. And part of that in this A3 thinking, or your plan here, is the Plan, Do, Study, Act. It is a piece of how you solve problems and improve processes. but it's only a piece of it. It is not the answer all questions. Okay, so don't take it as such. So for the continuous process improvement, the framework here, there are a number of steps. We will get through them as we go along here. But first, do we perceive the problem? Do we understand what the problem is, right? That's important before you start improving anything. You know what they say? So all improvement is a change. Not all change is improvement. So you need to find out what your problem is to improve the right thing. All right, so you need to grasp the current situation. How do we do that? How is it we find out what the current situation is? You observe. Where do you observe? In Gemba, right? Where the actual people do the actual work in the actual place. There you go, the 3 actuals. Value stream mapping, as I said, we did a little bit yesterday. So we need to find out what our value streams are. Have we mapped the end-to-end processes here? The information flow? Do we know that right now after our little simulation exercise here? We have an idea about it, right? My perspective sitting over at table 3 here was that the information flow was maybe what we had the most difficulty with, finding out how that is connected. I don't know what was your experience here? Was it the physical flow of patients, or was it more the information flow?
Information.
Yeah, so maybe that would be valuable to find out about that. And then you add on the process data. Also, like we talked about yesterday, add on things that will give you valuable information, but don't clutter it with all information under the sun, because it ain't going to be useful, and you won't have space for it if you do it on your A3 as well. Okay, so you need to think about what metrics represent the system performance. Okay, wait time, throughput time, financial performance. All right, so no, not so much talking from here. 15-minute exercise, okay? Develop your process map as it looks right now. Not the anticipated future state, but what does it look like right now? Write your process steps on your Post-its. You have the easels that you can put them up on, and you can connect them. And just before you start, add the decisions, right? The weights, the holds, and the inventories. Are there pile-ups? And look at this one. That's how you can look at it. Inventory or weighting, triangles, task, rectangles, burst, if there are issues, diamonds, decision points. Okay? Try to do that. You have 15 minutes, so 11:15.
So this exercise is just like yesterday. You should be writing at kind of the exam or whatever, the single sticky per process level on these. Do them first, then the inventories and decisions, and when you're quite satisfied with all that on the stickies and you have them arranged right, then tie them together with the mat.
The only reason you go to discharge is if they've already been to the lab. I guess put that there too, though, because it's an option.
So it will make it a little different.
Just make
because
these in pink.
this has to come back here, you know? This positive.
Right.
Yeah,
And
positive
the
should
fail has
return.
to go back there too.
I think we get another decision point here of if previous tests. Right, because if there was a failed test, then they have to go back to here. But if there was a positive test and they've already been, then they go back to discharge.
We can go test result here.
Okay.
Okay, so everybody's gotten pretty close. They're still tweaking some stuff. They're realizing that when you try to map out this process, although it seems fairly simple, it isn't. It's kind of complicated, and it's complicated in a couple different dimensions. What I'd like to start with is just to have, why don't we start with you folks briefing your map. Just real quick, because everybody knows the process. They've got the same one. Just brief how you mapped it. If you could do that.
So we put our 3 big decision points made by triage, the MD, and lab as these green diamonds. And then instead of having a waiting room, we treated all of the waits times with these upside down triangles.
Okay. So that's nice. It's functional. There's one thing that you sort of abstracted, which is that issue of everything going back to the waiting room, which you distributed, which is fine, right? You have to make that decision, but you sort of abstracted that. And the other thing, of course, is the fact that there's a dependency. The lab results often affect what the MD has to decide, right? So there's an additional complication which isn't captured at this level of detail. You could capture it, but it would essentially be more detail on the decision making. Yeah. Right. Yeah. Or just multiple decisions that the MD has to make. Has this patient been seen? Did they fail their lab test? Etc. Did they get a positive result? Because that affects where things go. That's cool. So now let's have you folks, just by way of contrast, tell us your strategy for plotting out the value stream.
So we had the different tasks that people have to do, which were all in green. So scheduling, registration, triage, etc. But we represented the waiting room as a physical location. So it's like kind of a mix between that spaghetti chart and the value stream map.
Yep.
So basically in between every single task, they have to go back to the waiting room. And so we also didn't quite finish, but we tried to have like the dependency, like when you get to a test result, if it's negative, you go back to the waiting room and then discharge. If it's positive, then something else happens. And the MD has to decide, based on the previous test, what to do.
Yeah. Okay.
And they also started putting times in there. I didn't finish that.
Okay, but that's kind of our next step, actually. So they're ahead of the game as usual. This table's good at that. So you guys can finish up your traces. But here they're taking a more physical approach, right? And the maps capture different things. It's sort of hard to see the flows and decisions because everything's going back and forth to the waiting room, right? So it provides a sort of a visual confusion factor. But maybe the issue is that everything's going back to the waiting room. Maybe that's like, an issue that we need to deal with because that is obviously confusing. It also has an awful lot of waste of motion in there with the poor patient and the potential for confusion that engenders. And I can see your strategy, although you didn't finish, that there's actually individual paths here which are going to get more complicated as we get to failed diagnostics, where maybe you could use a different color to trace the extra ones through there. So you can follow it, but it's a bit tortuous. But it does capture certainly the chaos of the system quite nicely. So and why don't we finish here and see what you guys have? You want to say something about it?
Okay.
The videographer can shoot you.
We have each of the stations in the blue. I think the main source of chaos for us was what happens with the exam process and the decisions afterwards. So that was our main point of contention at the end of this process, is where do we put all these negative, positive, failed test outcomes, and how do they eventually link back to the patient discharge process?
Okay, so and you've got some color going there to sort of try to chase that around. Okay, so
these are all value stream maps for the patient, but we don't have the information flow.
right, there's some other
Charts
things
and
there.
paperwork flying around.
That's right. And we did say we were following the patient value stream, but there are some other value streams up there, the charts, the paperwork, which we actually could use pretty much the same map to chase, but they also have their own chart room and record room. And to some extent their own processes. They don't follow exactly the same path as the patient. So, so this is good. So why don't we continue with our exercise?
Yes. So remember yesterday we talked about different times. We talked about cycle time, the time from the beginning to the end of the process, the touch time where the actual work is being done, where you exclude the wait times, and then again, value added, non-value added time. So we talk about some different types of time. And obviously it is the value added time that we really want, and we would prefer to get rid of the rest of it. So then there is also, when we get to the capacity things as well, you need to think about failed tests. This is not 100%, right? You have a certain amount of your test that just, they're neither positive nor negative, they're just failed. Hospital systems for us, what I have in my face every day is potassium, right? Do you experience the same things? You get high potassium, everybody gets scared because it is dangerous. You need redraws, and we used to be around 20%, and now I think we're down to 7% through leaning it out. But 7% is still a lot, right? Because, like you said, what does everybody do when they come to the hospital? They get lab tests. So we have probably a couple of patients every day referred to the emergency department for hyperkalemia that we redraw, and then it's negative, normal. So that's expensive. So
why don't we, because this group seems to have sort of caught the basic issue, and some of them have already jumped ahead, and what we want to do is add some time and reliability data to our map. The tricky thing is, of course, every patient is different based on the dice, right? So we have to pick some kind of unit of analysis, an average, a median, something.
Min and max, right? Maybe.
A min and max. Right. So we need to decide what our unit of analysis is and be consistent. It almost doesn't matter what it is. Over a long experience with these things, I've found that doing a min-max average is easily enough detail. When you start putting min-max average on all of these, you suddenly realize, I got a whole bunch of numbers here. And it's enough to tell most of the story. So we don't need a deep statistical analysis of these numbers, but we need we need to decide what our unit of analysis is, put the times up, and the times can pretty much be the hourglass. If there's a little bit of non-value added touch time, if there's a little bit of futzing time or confusion time or waiting for supplies time, you can add that as well. And put those times on our processes, and then the percentages of different decision outcomes, again, need to be estimated. Some of those are based on the dice, so you sort of have the numbers in front of you. Some of them aren't so much. When do they go to the hospital? Well, when the right color head shows up. When does that happen? You don't know. You just have to kind of estimate based on your experience, okay? So not too complicated. Let's take another 10-ish minutes to finish our maps and annotate them.
I love math.
So you're doing a weighted average for our...
Yeah, so if there are two patients waiting, one will be wait for this much, and the second patient will be waiting for 2 units of this. Yeah. And if the third patient will wait for 3 units of this.
Okay. But we have to kind of average over all that. So on average, how many patients do you think we're waiting? So her treatment time is 3 times the dice roll. Okay. Of which only 1/3 is value added time and 2/3 is waste. The average time a patient is in here is 80 times 3, which is 240, which is 240 seconds.
Okay, so should we just put 240?
240, of which 80 is value added.
So how about we put average time and value added
okay.
time? Okay.
There's basically 2 ways you could tackle the challenge of collecting data in the sim. You could, and I think different teams did it different ways, which is an interesting thing about this group. It's a fairly sophisticated group. I think that people have grasped the issue and made different decisions about how to tackle it. You could go in and you could say, well, okay, if I rolled an infinite number of dice, what would be the sort of statistically likely outcome? What would be my sort of weighted average time? What would be my weighted average of different outcomes through the system? So you could do it that way. And that's something in the real world you could do if you had profound knowledge of the system, if you just knew that 30% of this kind of patient went this way. And or other approach is you could use data, right? We have data. So you just count them, right? Which ones went where? How many dots did we have to do? How much rework was there? Problem with that is that it's small n, right? It's not going to give you the same answer as the statistical study unless you have a really large sample. Now, is that your world? Pretty much, right? In fact, medical studies tend to not really converge unless they have really large samples. So, But this is real. This is the reality on the ground. Which one do you trust? Which one do you believe? You have to choose, right? There's no absolute answer.
It depends on what system you're in. So at BI, we probably have the most advanced medical records in this country. So we can pull everything out. And we can go 10 years back, 50,000 or 55,000 visits in the emergency department per year. And we could just pull all of that out. It's fairly easy, but that's because we have good people. But that's not the reality everywhere. So I work with Iceland and with Denmark, and well, they have fairly sophisticated electronic medical records, but a lot of it is still on paper, and you just need to go and look at the paper. And at BI, our record has limitations too. Let's just say we want to study sepsis. We want to study the antibiotics that these patients they got. I can electronically see what got pulled out of the Pyxis. You may be familiar with the Pyxis locked cabinet. You punch in the patient's medical record number and what you want to pull out. But I need to look at the paper to see what the nurse gave. Because one thing is that they pulled out 4.5 grams of X, Y, or Z, but if they only gave 3 grams, that information is only available on paper, as it is. All right, good. So yes, you can go either way.
And that's
here, with the numbers that we added on, we added a little bit fudge because, well, when you handle stuff, it takes time. 15 seconds for just handling the patient to the waiting room, passing on the message. New patient takes time. There is a range of how long the different steps they take and the weighted average plus the fudge. Okay, so it's hopefully pretty similar to what the different groups found, maybe. Take a look.
Yeah, did you do something kind of innovative here? It's
We calculated the actual waiting time for the patient in MD. So the process time, so if it's one or two on a row, then it's 1/3 probability of 30 seconds. And if it's 3 to 4, it's 1/3 probability of 30 seconds. And then I calculate all of them and sum them up. So for one patient, the average value added time is 80 seconds.
80 seconds, okay.
Yeah.
All right,
But then there's another important step.
Yeah.
Is that she's got patients waiting.
Okay.
Yeah, so if one patient is waiting, and he probably will wait for the value added time is 80 seconds. And if 2 patients are waiting, so this is 80 seconds, this one will be 160.
Okay, so there's an issue. And notice that we didn't even try to estimate the waiting times, right? So she's gotten extra sophisticated and said the 80 is actually, we tacked on 15 seconds for paperwork, and so we're agreeing on that exactly. What she's doing, which is very clever, and this, you probably do need to do database. How many patients did you have waiting typically? So, yeah.
So she estimated that she has 2 patients on average waiting.
Waiting, okay,
So the
that's
actual
right.
time in the MD was 3 times the actual treatment time.
Right. So if we have
240. Yeah.
Yep, yeah, and that's great, right? That's going deeper than we did in our example, and that's right. Anytime you have inventory in front of a process, yeah, it's going to have to something called Little's law, which we'll talk about next time. You're going to have to wait essentially that number of cycles to get through the process. So if there's 2 patients waiting and one in exam, it's going to on average take 3 cycles to clear a patient through there. So so that's very good.
And then if you look at your how long time things they take, you should also get a sense of what the rate limiting steps are here. What would you say? When you look at it, who's the limiting step? MD in the lab.
Yeah.
What's the difference between the MD and the lab? The MD is one person, and the lab can do how much at a time? 3, with a little bit of good luck, right? Because they can do 3 different things at a time. But if you look at the times of the lab, well, 45 to 205, same for the lab, but the MD is really only one and can only be one place at a time. So And then there's some rework.
And that too, we have it's essentially the same issue, right? People can look at the dice and guesstimate, or they can look at their data and figure out what the rework rates are. The thing that actually you can't do there is that some of that depends on the patient color, which you don't know, right? There's an externality there that you don't have any control over. And if that's true, all you can do is look at your data, right?
Yeah.
You don't know what the big world looks like. You only know what your data looks like. So based on that, you should have something on this order, right? Something on the order of half of the tests don't go so well. So that's another major detractor.
All right. So diagnosing root causes, you need to find out what are the causes here. What's the effect? What's the cause? It's nice to separate those out, because the root causes, if you can find and affect those, you have a better chance of improving your system. We haven't talked much about workaround, but it's very prominent in the medical field. So I think, the medical field and the engineering field, I think that we have some of the same attributes. It is that we fix problems, right? We see a problem, we fix it. So I have a problem at work, I just fix it. I don't go back and say, all right, why is it that it takes 15 minutes to do a lumbar puncture? It's not that it's the 11 minutes it takes to find the stuff and get everything ready. I just go ahead and I do it. Or if it's a new resident, I'll help them and collect the stuff for them, right? Instead of saying, okay, we need kits. We need the stuff to be available in the area where we use it, because that's a long process. It involves our nursing leadership, physician leadership, and restocking guys, and it's someone else's area of responsibility, and they're going to be upset if I say this is all wrong. And so we do workarounds. That's not a good way of doing it. You can do root cause analysis in different ways. The 5 whys we talked about with the Jefferson Monument, it's very interesting. It's really useful. If you think about a medical system and say, we do too many joint replacements. Why do we do too many joint replacements? Well, because the joints are worn. Why are the joints worn? Chime in here. Why do people get joint replacements in the US? Yes, obesity. Why are people obese? Again, these things are being answered in a personal manner, right? So you can end up with different things. But I think you're right on. Processed food is cheaper than making your own food, right? And then it gets into who earns what. So you do why. Pre-processed food is cheaper than the other. Why is it? Because we put garbage in the food, and why is that? Blah, blah, blah. Okay, so 5 whys really work. Okay, and it works on many different things. It's not only the Jefferson Monument, which is nice too. We can do capacity analysis. We looked at that yesterday. Remember, how much time is available? What is our cycle time? Again, limited by the slowest steps in this process. All right, so tomorrow you're going to look at cause and effect diagrams and some Pareto charts too. This we're just going to stop. And pitfalls, they can be answered differently. Some is based on values and on opinions. If there's too much difference, then maybe you need a more sophisticated tool for that particular problem. But in general, it's going to work well on many problems. Good place to start. Yeah, it's difficult to identify all the possible causes. If you have input that's higher than your capacity, then you're going to have a bottleneck, and then you're just going to have a build-up of things that are waiting. Example from Denmark, pardon me again. So there is a plan that says, for instance, pancreatic cancer patients, you should be able to have surgery within, I don't remember if it's 2 or 4 weeks. One would hope that it's tomorrow, but it's 2 or 4 weeks. Nonetheless, they don't have the capacity to do that. And then you have a buildup of patients, and some of them, they get surgery 2 months later, maybe 3 months later. Others, what happened to them? Well, when it's cancer, you know what? It becomes inoperable, right? and then they drop off the list. Okay, so when capacity and supply is mismatched, you're going to have a buildup. Theoretical capacity. So this is a very cool field. You'll have more about that tomorrow. So maximum capacity is, well, the maximum sustainable flow rate at any activity. We like to think about 100%. Hugh is going to tell you tomorrow that that's actually not really attainable, and it's not an attractive a goal, because it will not function. It will lead to longer wait times and things like that. Effective capacity takes into account the errors, the distractors, the reworks, what you can actually achieve, and we can look at that. So if you can see 5 patients per hour, but you have an error rate of 20%, then in reality you're only going to see 4 patients per hour, right? Okay, so that's your effective capacity, not your maximum. All right, let's see. We can look at about this one here, capacity calculation, time available, we know that. And then the cycle time, the time per unit, time per round, your number of resources that you have. But you're not always available, are you? You're not available 100% of the time. People, they go to eat, they have bathroom breaks. In Europe, they smoke. And some places, that is being taken out of your work time now. I'm not kidding. But that's a new concept. It never used to be. So I think smoking will go down with that. I think it's an excellent step. No, I mean, and I'm not kidding. The actual touch time where you're doing something that is useful for the patient, and then the number of repeats, the failed test, or the, I had a positive test, I need to go back to the MD, as in our simulation here. So you put that in the equation, and then you get your real capacity. The green ones are the good stuff, and the red ones are the detractors. So this is basic concepts. It's not, people, if you go back to your organizations, they might be confused by the words that you're using, but if you talk about this as a concept, then you should all be on the same page. So now we have 10 minutes to do a root cause analysis for your clinic operation here. So identify causes that can be remedied using lean principles and tools that you heard about yesterday. Try to put it on your easel, and let's talk about it.
So think a little bit more about what's wrong. You can finish up your value stream map, and why don't you go ahead and actually, rather than do a separate easel chart display, why don't you go ahead and put your suspected root causes right there on the chart. You know, is this the problem? Chaos in the waiting room. I don't know whether that's the root cause. That may actually be a symptom, but we'll put that right on the chart. So we'll finish the morning with an annotated chart of the things that you want to fix. And after lunch, we're going to proceed to fix them.
So it sounds like we've identified 2 major problems. There's a bottleneck here, and there's a solution to get the RA trained. And then the failing equipment there, we got to find some solution for that. And then those are the 2 main kind of long poles in the tent. And then next level down is streamlining the ordering system. And this kind of just flow through the waiting room.
Also optimizing the order that we get patients from the MD to the diagnostics, so that I can run a couple at a time.
So we're doing that. Yeah.
Oh, okay. So we actually want to have this distributed waiting room type of thing?
No, that is just so she doesn't, like she has to pick which order she sees the patients in.
If I'm treating a gray patient and she's got a gray patient, a blue patient that she's trying to decide who to treat next, pick the blue one so that I can run it at the same time.
So this is a visual control?
Yeah.
Okay, cool.
Let's talk about the conclusions you guys came to on your root cause exercises. If we could just go around and just tell me 2 things that you think are the biggest problems with your processes from a sort of root cause perspective. We'll start back here.
So our main problem was the bottleneck in the exam room.
Okay.
So when it boiled down to the root causes, we thought it was due to triage failure, so potentially due to inadequate training here in triage, as well as test failures due to equipment issues, for example, lack of maintenance, more training required, and a protocol that just would
make the
Yeah.
process less efficient.
Right. So the rework issue from diagnostics is easy to understand. What was the issue with triage?
So we potentially were thinking that we could start cross-training staff between registration and triage, because this might just be a step that we don't need necessarily.
Okay. So you think there's some inefficiency there?
Well, in
But-
triage, the doctor was seeing levels of care that were either too easy, that could have been managed by triage, to
Okay.
either discharged to home or sent to the hospital without ever seeing the doctor, so he could
Okay.
have seen fewer patients if triage was.
Okay. So there was triage was feeding unnecessary work to the doctor. Okay. You folks, what's your top two?
I think one of them is too much patient movement, having
Yeah.
them shuttle back and forth to the waiting room. It created a lot of confusion, kind of for all areas, in that we didn't know where they were
Yeah.
supposed to go next. So that kind of covered actually a couple of them. We also had the inefficient registration triage system, and also the bad information flow, where the chart was getting separated from the patient and going to the chart room
Okay.
in between each time. And really, one way to solve that would be to keep the chart with the patient as they move through the system.
You focus more on the detractors for the bottleneck, while as you guys are focusing more on the overall process issues of the confusion of having the patient move. Yeah, these are both valid. It's interesting that folks are getting kind of different. So who wants to speak for this table?
So we also agreed with them, so I won't reiterate that point, but one minor thing that we noticed is we had a lot of unused capacity in diagnostics.
Okay.
And we had a backup with the physician, and the physician didn't have a method of choosing which patient to see next. So we set up
Okay.
a signal system whereby any unused device would kind of be sent in front of the eyes of the physician, so that she could pick the right patient to see next and send right back over to diagnostics.
Okay.
That's a lot.
So looking at the sort of outflow from the physician, making sure that patients didn't have to wait on the other end as well. Yeah.
That's a really good instance of pull.
Yes. Yeah.
Okay, you can see what the diagnostics could use, and they really have something set up almost like a Kanban.
It's almost like a pull Kanban. Yep.
Yeah.
That the patient is pulled into diagnostic based on the availability.